Greetings, Earthlings. Today's going to be Intro to Geometry. We're going to be starting our geometry section, and we're going to go over how to draw a good diagram. So when we do geometry problems, step one on a lot of these problems, and I'll keep saying this, is draw a good diagram. If you're trying to solve some complicated geometry problem without any diagram, you're really missing out on a big piece. Alright, so what makes for a good diagram? And also why I love geometry. So let's get this part out of the way, why I love geometry. I think it's one of the more intuitive and fun aspects of mathematics, largely because it's very visual. And also there's the stigma of math is just number crunching, and geometry will be definitely one of those areas where we'll see that it's not just number crunching, there's a lot of strategy, and it can be quite artistic. It's pretty beautiful. Alright, also geometry appears in nature, so that's why it's also one of the earliest branches of mathematics, such as like with the Greeks and many other cultures that saw a lot of development. So I think geometry, even more so than counting and adding and subtracting, is probably one of the first branches that we may want to teach kids. Although I started this series with adding and subtracting, geometry can very equally be taught first. Alright, so that's why I love math. Now, pardon these really fabulous cleaning implements, but my eraser took a trip. Alright, so we're going to go through what makes a great diagram, and really I just have to say one point, which is the first one. It has to be qualitatively good, and all of these are kind of encapsulated in that first point. But let me jump to point number 4 really quickly. In one word, what makes a diagram good is that it's useful. So it can be as nice as you want or as bad as you want. If it's useful for you and you could solve the problem at the end of the day, it was a good diagram for you. So don't worry if I think or your friend or your teacher thinks it's a good diagram. If it's not helping you solve the problem, it's not useful for you. Alright, so that's sort of a key word. But the key concept I would say is qualitatively good. So let's discuss what that means. We have qualitative and quantitative. So the difference is quantitative deals with quantities or numbers. Qualitative deals with qualities. So if I say I'm taller than you, I'm shorter than you, I'm fatter than you, those are qualities. I'm not telling you by how much, I'm just giving you a direction, up or down. Quantities would be I am 316 pounds or I'm 584.629 inches. Alright. So we don't care if it's precisely, the details don't matter, so it doesn't have to be quantitatively good. So let's see what I mean with some of these examples. So let's say we have a 6x4 rectangle and you want to draw this. So here's our 6x4 rectangle. Now what you don't want, so qualitatively good, clearly this side is longer than that one, so you don't want to label this 6x4. That would be qualitatively bad because the shorter side visually has the larger number, so that's not good. So provided you did this for your rectangle and maybe even put the units like 6 inches, 6 feet, whatever, that would be great. Now here's what you don't want to do, and let's jump ahead to point number 5. So we're going to sort of be hitting on all these points. You don't want to waste your time on unimportant details. So in point 4, you want your diagram to be beautiful, large, legible, and clean and uncluttered, but you don't want to be an artist. So don't be Picasso. So, it doesn't have to be quantitatively good, which is sort of related to this point. So don't take out your little ruler and say, wait, hold on, this is not exactly 6 inches. It has to be over here. So that's a waste of your time. So don't, this is good enough for our purposes. Now we may want a larger diagram if we're doing a lot of work and drawing a lot of things, but this is a good enough rectangle. Alright, so that's qualitatively good. Next, an isosceles triangle. So let's say you have an isosceles triangle. You don't want to draw it like that. So maybe you labeled it so these tick marks indicate the sides are the same. What's wrong with this diagram is number 3. So while this indicates these two sides are the same, it also assumes a special case because visually this is a bit misleading. It looks like the third side is kind of the same length. So this looks like an equilateral triangle where all of them are the same length. So I would say if you're doing an isosceles triangle, probably something like that would be good. the qualities are, it's in the ballpark. It's pretty good. So these look the same, that looks different. And you want it to be useful, so it's giving you the general good ideas to proceed for the problem. All right, so that's with isosceles triangles. Now let's say this is a more subtle point. So let's say you have a 60-degree angle, or 62, 63, whatever. So let's say this is your coordinate system, and we'll go into this more later. This is x, that's y. And this will be 45 degrees. It's split right down the middle. And this will be 60 degrees. So this whole angle. Now, what I care about qualitatively good means you drew the 60-degree angle to be nice and juicy like this and not like super tiny like that. So, in other words, you could tell that it's a bit larger than 45 degrees. So, we just want to know, is it more like above 45 degrees or below 45 degrees? So if you have a 30-degree angle, it would be sort of thin. That's all we care about. You don't have to ace it and get it exactly 30 degrees. So that's what I mean. Make sure it's in the ballpark. It's getting you the idea that 60 degrees is a pretty big angle. It's between 45 and 90. That's really all you need. All right. Next. So label all the important features. So if you're given information such as a 6x4 rectangle, you've labeled the 6, you labeled the 4. If you have information like some angle is 37 degrees, you labeled that in your diagram. We talked about don't assume a special case. So if you want to prove some general thing about a triangle, maybe you draw a triangle like this, where these two don't look the same, and that, in other words, this looks short, that looks medium, that looks long. You don't want to draw this nice looking equilateral triangle, because that assumes a special case. Even if you didn't assume it in your math or algebra, visually it might mislead your thinking. All right. And also, I'll put a link for this, but Professor Tokeda talks a lot about having nice diagrams, and his background is actually in art, I think, drawing or sculpting, so I'll put that in the description. All right, so we want beautiful diagrams, or more useful might be a better word. I am very guilty of not doing number 4. So I used to be the master of creating these little tiny diagrams and then putting like 37. And it would be so small, and I would have something in like the corner of my paper, and I would just have a really hard time. So when you're in a rush and my handwriting's not that great, as you guys already know, if your diagram is cluttered or it's small, it's not just about the diagram. Your brain starts to mirror the diagram. So if the diagram is all messy and cluttered and you can't really see what you're doing, inside of your brain is that equally crammed soup. So your thoughts aren't great. You're going to miss creative ideas. So you want a nice diagram that you can work off. All right. And like I said, don't be Picasso. This is not the time to draw elegant diagrams. Now, if you have a little bit of time, let's say you're a teacher or you're a student for a presentation and you're going to be spending like 30 minutes just dealing with 1 or 2 diagrams, then yeah, make them nice. But if this is an exam or anything, just get to the point. Make sure you have the important qualities. It's qualitatively good. So let me give you an example. Let's say there's a cube. So here is a reasonable cube. Now, we can leave it at that. Let's say it's a 5 by 5 by 5 inch cube. That's a decent looking cube. Is this perfect artistically? No. Perhaps this should be a millimeter or 2, whatever way. Now, let's say I want to see it a little more in 3D, so I can add these dotted lines. That's really all we need. So maybe a lot of problems might say find the length from this point to that point for that long diagonal. We'll go into that problem much later. But the point is, this is a nice working diagram. It's not super beautiful. It's good enough. It's useful. We can work with it. So don't get hung up on like, I have to. So like a pyramid, you could draw a square, connect them to a point, and get going. Now, see this diagram, is already getting a little uglier, but you guys got the idea. So make sure it's good enough, it's useful, it's working, it's not this tiny cram diagram, but don't get too hung up on it. So these are sort of, I put this red arrow here because these are extremes. On the one hand, we want it nice and workable, but on the other hand, you can get carried away with this and you're wasting too much time making it too beautiful. So don't rush it, but don't take too much time on it. All right, that'll be step one, how to draw a good diagram. I will see you guys in the next video.